In this video, I'm going to be talking about limits. Limits are part of the fundamentals of calculus and the basis of more complex concepts in calculus, such as derivatives and integrals. So let's look at an example function. F of x equals x squared minus 4 over x minus 2. So you'll notice that we can actually factor the top part, and we'll get this. And then we can also cancel out these parts because they're the same. We just divide by x minus 2. But you'll notice that if we do that, the value of f of 2 will change, because up here we'll get 0 over 0, so we'll know that f of 2 is undefined. But if we were just simply exclude the x not equal to 2 part, we'd get f of 2 equals 4. So we'd get undefined here, but we'd get 4 here. So we have to make sure we include this part, because what otherwise would be changing the function. So if we were to look at both of these graphs, you'll notice that they look very similar. They look like the exact same line, except for this one point over here. As we said earlier, at f of 2, f of x is undefined. So, but over here, y equals x plus 2, we'll get that y to equal 4 for x be equal to 2. So this is where limits come in. If we wanted to say that this point, it looks like there should be a point at 2, 4, we can kind of express this with limits. So the way we would write this is that the limit, so this is the first part, and you'll see this in every limit that you write, as x approaches 2. So as x gets really close to 2, so say x1 here, and then it gets really close, it becomes 1.99 and then 1.999 repeated basically but it's not actually a 2. F of x, so we're plugging x, the value of x that approaches 2 into this function here, so we'll be getting this. We want to say that this gets really close to 4, so we just say that's equal to 4. So this is one expression, and then this is the equivalent value. So this shows what variable is approaching what, and then this is what the expression that we're using this approaching variable to be, and then this is just what it equals. And to be clear, this applies also for y equals x plus 2. It doesn't matter whether or not it's defined. We're just looking at what the function behavior is as it approaches that value of x. So we can write the same thing, the limit as x approaches 2, so as x gets really close to this point here, this line of f of x of this function. So if we plug those values in, as it gets really close, it approaches 4. And in this case, it actually does reach 4, but that's not what we're expressing with this. Now we can also look at another function to show limits. So this is the graph y equals 2 to the power of x. And as x becomes really big, as it becomes infinitely big, x will approach infinity because it just keeps going up. But if we were to look at it, as x goes really small, as it gets really small, 2 of x approaches 0, because we know that there's a horizontal asymptote at y equals 0. So if you were to look at the function on the left-hand side, you'd see that this line just keeps getting closer to y equals 0. So that's why it's equal to 0. So this is how you'd express those functions in terms of limits, the end behavior, or you also look at any point over here. So say we wanted to look at the point 3, 8. We could say the limit as x approaches 3 of 2 to the power of x is equal to 8, because we know that from both sides it looks like it's going to approach 8, and it is in fact defined at 3, 8. So in the next video, we'll be discussing how you can use algebra to solve limits, and you don't have to look at a graph or know what the graph of it even looks like. So make sure you watch that video, and if you have any questions, please put them in the comments.